In this video, we're going to be looking at an exponential function. Okay, before we discuss the equation written on the graph, let's remind each other that the basic form of an exponential function is a b to the power x plus q, right? Perfect. Where q is basically your asymptote. Q is your asymptote. So q is the line that you're not going to touch. A basically tells you the steepness of a function. Perfect. So now, without wasting time, let's go into the section. Okay, let's go into the section and discuss this. Okay, we're firstly going to investigate the effect of Q. Okay, we're going to investigate the effect of Q. Okay, let's check. In this case, Q is what? It's -4. Do you see it in this case? Your Q is -4 there. Right. Now, if you check on the graph, -4 is here, right? And it's your asymptote. You see the graph. If I zoom out more and more, you'll see that the graph does not actually touch this line of -4. Ne? Perfect. Let's make it -3 and see. Ne? You see? Now it's there on the asymptote is on -3. Do you see? Okay, we're going to make it positive 4. Let's see, positive 4. Where is our graph now? Our graph is now having an asymptote at 4. Do you see? So this value here, it's your asymptote. Ne? It's where your exponential function is not going to touch. That is very important. You need to know it. And it's always y equals to q. Ne? It's a y value because it's passing through the y-axis. Ne? It's line y equals to something. Perfect. So we discussed the asymptote. Now we're going to discuss the effect of A. Ne? Let's check what A does. Okay. A basically tells you the steepness of a function. Ne? It tells you the steepness. For example, if I increase this value here, ne? You'll see that the graph gets steeper and steeper and steeper. Ne? So A tells you the steepness, right? Now let's check the signs on A. Ne? Now it's positive, the graph is, if it's positive, the graph is above, the asymptote. Ne? If it's positive, the graph is above, because your asymptote is in the graph, it's above. Ne? Now I'm going to make it negative. Let's see. Oh, sorry. Let's make it negative and see what happens. You see, the sign here tells you basically if the graph is above or below the asymptote. If the sign in front here on A, it's negative, it just tells you that the graph is going to be below the asymptote. If it's positive, the graph is going to be above the asymptote. If it's negative, the graph is going to be below the asymptote. That will be very important when you determine the range of a function. Okay, perfect. And then you should also know that B can only be positive. Ne? It cannot be 0. It cannot be a negative number, right? Perfect. Then now let's answer some questions based on this function here, the one that I drew. Okay, sure. So let's find the asymptote. So the asymptote will be y equals to 4, ne? Positive 4. Remember, the asymptote is this part here. And ladies and gents, don't just say asymptote and then you write 4. That is very incorrect. Ne? You must always say y equals to 4 because an asymptote is an equation of a line. Ne? So it must always have y equals to something. If it's in x, it must have x equals to something. Okay, perfect. And then now we're going to do domain and range. Ne? Domain. So remember, you ask yourself if there's a restriction on X. This graph does not have a restriction on X. Why? Because it keeps on going to the left and it will also keep on going to the right. There's no restriction on the x-axis. There's no restriction. So your domain for exponential is x elements of real numbers, right? Because there's no restriction for x. But the range is going to have restriction because we have an asymptote in this case, right? Sharp. Let's check what the range is going to be, right? So this is how I determine my range. I know that the range is what? And I know that this is the restriction. So I'll put 4 there. I always put my y and my restriction. And then I check this sign here. This sign here, if it's negative, it tells me that this number is the highest. It means the graph is below this number. It's below the asymptote, just like here, if you can see, right? So 4 is the highest number. So y must be smaller than 4. And don't put O equals to, because this is the asymptote. We're never gonna touch it. All right. Perfect. Now let's find, we're going to find the x-intercept and the y-intercept of this function. Okay. So clear all. Remember, for y-intercept, we make x 0, right? X must be 0. So y-intercept is the easiest thing, right? So you have y is equals to -8. You are writing the function the way it is. And then you have 3. When you see x, you put 0. So it's going to be 0 minus 1 at the top, then plus 4, right? And then what does this give us? Let's check here on the calculator. Okay, so let's check on our calculator. So we're going to type in -8 in bracket 3 to the power of, I can see that 0 minus 1 is just going to be -1. And then plus 4, right? Plus 4, I mean. It's 0.75, ne? No, I mean 1.33. Sorry about that. So here it's 1.33. Then you always have to write it in point form. Ne? Remember, x was 0. And then your y value is 1.33. Then you close it. Ne? That is your y-intercept. I mean your x, yeah, your y-intercept. So now we're going to do the x-intercept. The x-intercept, okay? So the x-intercept, you make, remember, x-int, y must be 0. So I see y, I'm going to put 0. So I have 0 equals to -8, 3. Then I have x minus 1 plus 4, right? Perfect. When you solve for exponential equation, you always need to isolate the part that has an exponent. So I need to isolate this part. So I'm going to remove the 4 first because it's not attached to this. I can't remove -8 first because it's attached. Whatever is attached to what you want to isolate, you always remove it at the end. So I'm going to say plus 4 becomes -4 when it comes that side. Then I have 8 with a negative sign, 3x minus 1, right? Then I'm dividing both sides by -8. I divide both sides by -8. So I have half, because this simplifies to half. Then this side I have 3 to the power x minus 1. Right, perfect. And then this part, I see that, okay, I can't make the bases to be the same because there's no way a half and a 3 can be made to be the same base. So if this is the case, I have to use logs. Ne? I have to use logs. So on logs, the exponent is the answer. So I have the answer here, which is x minus 1 equals to log the base. Remember, this is the base here. This is the exponent. The base is still the base then. And then what was the answer? It's here. Right. And then we can easily see that from there, if I move 1 that side, I'm going to have x equals to log base 3 half plus 1, right? Because 1 was negative. Now moving it this side, it becomes positive. Now let's punch this on a calculator and see what it gives us, right? Log base 3, 0.5, we can just put the fraction in half, and then plus 1, right? And then this gives us, let's see, this gives us 0.37. Remember, 2 decimal places, right? Then therefore, 0.73 coordinate is 0. That's your x-intercept. Now, since we're using a graphing calculator, I just want us to verify our solutions on the graph. Ne? Remember our y-intercept, we said it was 1.33. You can see it there, it's 1.33. And then our x-intercept is 0.67. Do you see it? The graphing calculator is set to round off to 3 decimal places, but we always use 2 in our context, right? Unless stated otherwise. Okay. And that's it about an exponential function introduction. Okay. So in the next video, we're going to be sketching an exponential function. I'll show you how to sketch an exponential function. We are still going to use this graphing calculator. Okay. Thank you very much, ladies and gents. Aluta continua.